Hello, my name is Pedro Serrat. This is Marybel Hernandez and Santiago Paz, and we're Group 10. Our project was robots and laptop assembly. As you can see illustrated in our picture, robot has an end effector of an eye. The eye is actually connected to a computer which will be analyzing its circuit boards in its area. The eye is used to determine whether or not the circuit boards has any problems and whether the circuits in general are working properly. If they are working properly, it's moved on to the next area of assembly. If it is not working properly, it'll be moved on to a different area where it can be either worked on or decided if it should be tossed and started over. Robots have been used for a variety of purposes. Some purposes have been for military applications as well as the medical industry. As far as the computer industry, robots have been used for general assembly as well as soldering different circuit components and miniature screws. As you can see illustrated in our circuit, the robot will have the necessary precision to work on this circuit, soldering tiny pieces as well as very tiny visible screws. And finally, general assembly as far as circuitry goes and the general assembly of laptops. Now Santiago Paz will continue.
On this slide, I'm going to talk about how robots improve our industries. By the time laptop came out, humans didn't have a big role in the industry, in the assembly line. This is because robots were already used by assembly process. The reason why is because there is no fatigue. They can work every day and without stopping at any hour. They're going to perform better. They're going to assembly a little faster. They're going to produce more faster than human being. On this picture, we can see they are testing right now heavy-duty computing by spraying some water on it. They want to see if the computer can support the water going in through the system and there is no short circuit on it. Also, the industry is going to save some money by eliminating daytime and labor costs. Right here on this picture, you can see how the assembly process works by introducing the computer and going through another step by step. Thank you. Now, right, so.
Okay, I'm going to talk to you about the design process. There's two main sections, the physical and programming. Under physical, you see like the actual building of the robot. It has to do with the number of axles, degree of freedom, the kinematics, length of extensions, carrying capacity, speed, acceleration, accuracy and repetitiveness. A lot of these robots just pretty much do one task, pretty simple, just pick up, drop, drill, just really simple, no-brainer tasks. Power source, also you gotta make sure that for the robot, as big or as small, you have a proper power source. You don't wanna waste any, and you wanna make sure that you can do what you need to get done. As far as the programming is concerned, you gotta have specific software, positioning commands, and singularity. You wanna make sure that it goes through all the positions and does everything that you need it to do without locking up or skipping anything. Here we see a robot, which basically goes through training. I know how that seems kind of funny, robots in training, but they actually do. They get the programs, their commands put into their programs, and they make sure and they get monitored to make sure that they go through all the processes and make sure they do everything exactly how they're supposed to. They all have little cubicles, like people that work in offices, but these robots, they're being watched to make sure that they're doing everything correctly. As far as our design is concerned, we're going to have, it's going to accomplish basically a simple task, picking up and dropping. It's going to go from point 1, it's going to pick up an object, go to point 2. It's going to, at that point, it's going to either be fixed, drilled, it's going to do whatever it needs to do. Then the object is going to be dropped, and it's going to return to its initial position to repeat the process all over again. As I already said before, these robots do very simple tasks. Here are different kinds of robotic arms, and some of them have a drill, others have claws, drills, welding, just different types of end effectors to get different jobs done. It all depends on what you want the purpose for. And then our design is going to go through a kind of like a triangular process path. It's going to start here at position 1, where it picks up an object, and then it's going to go up to position 2, where it's going to be worked on by some other robot, whatever that work might be that needs to get done. Then it's going to be dropped at this position, and it's going to be sent off to the next step. And then it's going to return to its initial position to repeat the task. Very simple, no brainer, just pick up and drop. And now I'm going to pass it on to Pedro, who's going to talk to you about the actual design that we created.
Our design was based on a 3-degree of freedom, 3-revolute joint robot. As you can see, this claw is the object the end effector that will be picking up our robot, our manufactured piece, lifting it up to our second point, to where that second robot or human or whatever needs to be done to that actual piece in the assembly line. Then it will be dropped down and placed on a second conveyor belt to be moved on to another process. Our robot arm will then move back to its original position, pick up a new object, and continue the process over and over again, as you can see in our video. Our robot will actually be moving. This is where it will be worked on. It will actually stay here as long as it needs to continue the process. Be brought down when it is complete onto the second stage, and then it would be starting all over again from the first part, and it will be going into a repetitive motion as long as the work needs to be completed. It'll just keep going and being worked on. And now Santiago will conclude.
For a conclusion, we conclude that robots are more efficient than humans. Also, they're going to perform some boring and dangerous tasks like we chose in our presentation. And also, they're going to save some money on it. Thank you.